There have not been many tower crane models made in 1:50 scale because of their resulting large size. But in 2008, Conrad introduced their model of the Liebherr 630 ECH 40, and fully assembled it was 2 meters high with a 2 meter span. Then in 2015, HK Functions Model Bau demonstrated a prototype of a radio-controlled conversion at the Nuremberg Toy Fair. And in this review we're going to take a look at the finalised version, and there we see a label on the standard Liebherr model box. It is a huge model in a huge box, and this converted model has been taped up to keep it all safe and sound. So after we cut the tape, there are 3 trays of parts, and there are lots of them. The top part has the jib and counter jib, the cab and mast sections are in the second tray, and in the bottom tray we've got the cruciform, the tracks and other parts. The base model comes with plenty of documentation, and the first brochure is a little unusual. It's really Conrad just saying how proud they are to have made such an impressive model. Next thing to look at is a sheet of assembly instructions, and it seems to be the height of optimism to think the assembly of this model could all be covered by just one sheet, albeit with different languages on the back. So Conrad have provided another much more detailed set of instructions, and that's much more helpful. This is Conrad's version 3 of the model, so there's another sheet containing variations to the pendant bars. But it's the instructions for this radio-controlled version which are the biggest. These cover the additional assembly requirements of the radio-controlled model, including the operation of the transmitter and what the various controls are. It also covers other aspects such as the lighting, and the more complex parts such as using the climbing frame. And we'll see more of all of these later. To begin the assembly of the model, we need to lay the track, and the first improvement on this model is that some of the sleepers are screwed in position. A total of 3 lengths of track are provided so you can have a decent run, and here we've set out 2 sections, and now we're placing the cruciform on the rails. Power needs to go to the crane, and so just like the real crane there's a cable drum, and so we pull off some cable and clip it in at the end of the track. Now we strengthen the cruciform with some additional beams, and then we can add the first of the mast sections, and this first piece is a special. It's special because it's got attachment points for some props, and another of the improvements on this converted model is that all the ladders are the right size and permanently fixed in the mast sections. We drop the mast section in place with the giant hand crane, and then all of the connections are made by Conrad's plastic pins, and they are very effective on this model. Next up we add 4 props to give some stability to the mast, and then we add some dummy ballast blocks. These are a dense plastic, so they do add some worthwhile weight to the bottom of the model. From now on we're basically going upwards, and the next piece of mast is another special, and you have to pay attention to the K sections on one face of the mast, because they must all be on the same side for the climbing frame. After that we're into standard mast sections, and a feature of those is that they make good heavy haulage loads. Now the complexity ratchets up a notch with the climbing cage, and this is a masterpiece of model engineering because it's fully functional, and we'll get to see it in action later. Another of the improvements made on this conversion is the addition of an extra ladder, and that goes up to an access platform at the top of the climbing frame. For some unknown reason, Conrad didn't model these on the base version of the model. With that bit of pre-assembly, we're then ready to install the climbing frame onto the mast. And one thing we have to watch out for is the power cable, and that's because it has to be on the right side of the climbing frame, because it has to pass up and through it to get to the crane. This gets to be a little bit fiddly to feed it through, but it's not a problem. Next we come to the crane cab, and again we can see there's lots of additional work here. You can see that the slewing ring is modelled and the motors for it are mounted where they should be. There's an operator inside the cab, and you can see all the electrical connections at the top, and there's a lot of complexity in the bottom, and all that's to do with the climbing function, which we'll see later. So once again we use the giant hand crane to mount the cab on the mast, and you just have to make sure the support beam is pointing the right way to fit the climbing frame. To get the electric power into the cab we plug in the cable at the top, And then we bring up the climbing frame and attach it to the slewing platform. And for this version of the model, special steel bolts are supplied. Now there's another big electrical connection to make, and that is to plug the climbing frame into the slewing platform so it can get its power. Onwards and upwards with the top section, and we drop that in place, and again it bolts in place with plastic bolts, and we make an electrical connection for the light on top. This crane can be built in many configurations, but for this review we'll only build the very smallest, so it's easy to video. The short counter jib is made up of only 2 sections, and then we can offer it up for connection. Again, plastic bolts do the job, and they slot in easily enough, and in doing this work the giant hand crane is starting to run out of enough hooks. So for the bigger pieces, 2 persons are advisable. We connect up the pendant bars, and there we have the counter jib erected and in place. As we go along we have to make electrical connections between all the sections, and that applies on the jib as well. And these specially made bolts are great because they provide continuity for the trolley rails. Time to use the giant hand crane again to get the first section of jib mounted. And it's just a repeat of the process using plastic bolts. And after joining the jib on, we just make the connection with the pendant bar. Of course we then need to add on the trolley because we need that for the crane to work. And after that we can add on the second section of jib. And this now represents the smallest configuration we can build. Another big improvement is the counterweight slabs because they each have their own slot on the counterweight jib. And they won't drop out. With the structure of the crane assembled we now need to do some roping up. And we've connected one rope from the trolley drive to the back of the trolley. And because jib lengths can be different, we need to pull rope off the clever storage reel that's provided. We run it over the front of the jib and then secure it with the locking screw provided on the trolley. For the hoist rope, we run the motor and pull some rope from the drum. With the rope work done, there's some additional detail to add, including a ladder and some access platforms. And as we are only running one trolley, we only need to add one access gantry. Starting with the undercarriage, the drive motors are realistically small, and as mentioned before, the mast sections have their ladders fully contained. The climbing frame looks much better with its working equipment and the additional ladder and top platform. The toothed slewing ring is visible, and the motors are a realistic size. As this model works, it's right to have an operator, so there's one in the cab, and at the back there's a warning light. The hoist motor is a realistic size, and the counterweight location lugs are visible. Also they have proper lifting eyes so they can be posed being erected realistically. Looking at a real Liebherr crane, one of the things you notice are the spoked pulleys, and that's also been put right on this version of the model. To control the model you need a high quality transmitter, and nearly all the function buttons are used by the model. For our start of the radio control we'll begin at the bottom, and as we see here the real crane can be mounted on tracks so that the area it covers can be increased. It has powerful motors mounted in the bogies, and they're able to power the whole crane along. This feature has been implemented on the model and it works really well. The speed is not only realistic but it's also variable. In action the mechanism is perfectly smooth and works really well, and the motors seem to have no trouble moving the model even though it's actually quite heavy. So in terms of realism this is just about as good as it gets. Not only that, but the cable drum for the electric power cable automatically spools out or winds in depending on the direction of travel. Now we'll try out the crane functions, and we'll begin by slewing it. And again it appears to move smoothly and at a realistic speed. So it actually looks like the real crane and not like just a toy. So again this particular function has been implemented really well. Next we'll go on to the movement of the trolley, and this is actually quite a difficult thing to model well. You need to erect the crane with the right tension on the trolley ropes, and when you do that it rolls smoothly along the jib, helped by the special jib connections supplied with this model. Also at each end of the jib there are sensors, and they automatically cut out the trolley motor if the trolley goes too far. The trolley speeds are realistic, although it couldn't quite run at the very slowest speeds. In contrast to that though, the hoist motor is great. It has a variable speed controlled by the joystick, and that includes dead slow, or if you want it can run along at a merry rate. The real joy of using it is that it's so responsive. Another feature is the working warning lights, which flash on and off irregularly, and they look great in the dark. Another option on the lighting front is to have an illuminated advertising sign. These are specially made up and they clip onto the counter jib. And here we see an excellent piece of advertising. If you've still not seen enough light, then there's more, because there's another option to have floodlights on the mast. Once again, these are powerful little LED lights, and they simply clip into the gap between adjacent mast sections. There are 4 of them, 1 for each side of the mast, and they are simply controlled by a switch on the transmitter. Now we move on to some difficult engineering, which is difficult in real life, and it's very difficult in the model world. And that is the process of making a tower crane higher by using its climbing cage. This model comes with a special lifting bar for lifting up the sections, and then you can bring it closely to the traversing beam that slots the section into the climbing cage. The design of the system is clever because if your driving skills are good enough, you can unhook the mast section without needing to use your hands at all. During climbing, the real crane has to be levelled out, and that applies to the model as well. And if you don't use another mast section as a weight, you can use the specially provided one. You move the trolley into a position where the crane is balanced. And now we start getting into the area where you need to concentrate. We're now unbolting the slewing platform from the mast, and that means we're able to use the powerful hydraulic ram on the climbing cage to push the cage up, and hence push the crane up. The motor and mechanism on the crane is very strong because the crane is a heavy load. But the jacking up all happens at a realistic speed, and actually it's incredible to see the climbing mechanism working in 1:50 scale. Just as on the real crane, the jack works in a series of jumps, and you can see that in action here when the ram reaches its full extension, which is 1 rung of K-struts on the mast. Then the top intermediate support is moved in, and you can now retract the ram so that intermediate support now rests on the next rung of the K-frames. The ram is now working in reverse and is pulling itself up, and by use of a switch you move it away from the face of the mast sections. When the ram is fully retracted to the top, you reverse the movement. It moves in onto the next rung of the K-frame, and then it starts to push up for the next jump. The model engineering is excellent, but you still need to keep a close eye on things, just as you would on the real crane, to make sure that everything's running smoothly as it should. This incredible functionality is not yet complete though. Once the climbing cage is high enough to get the section in, then that can also be moved in by radio control. Again, this works realistically slowly, and it's fascinating to watch it in action. Once the section is fully in place, the cage is lowered so the bottom of the new section plugs into the top of the existing mast. And when that's done, the bolts can be inserted. If you lower the cage slightly more, then the traversing beam can make its way out. And again, the remarkable thing is this can all be done without manual intervention. We can then lower the cage further so that we can attach the mast to the slewing ring deck. And at this point, just like on the real crane, manual intervention is required to install the bolts. Another option you have is to rig the crane in heavy lift formation with 2 trolleys. So let's use the big Liebherr to lift a large steel fabrication. Sometimes you just have to say that something is fantastic. And this radio-controlled version of the Liebherr 630 ECH40 is one of those times. The model detail is improved, the functionality is brilliant, and yes, it's expensive, but of course you get what you pay for because it's excellent.